Hi, everybody. Welcome to Beyond the Weather Brief. You do have a control panel over on the right-hand side. All you have to do is select the little red box with the three dots. And if you click on that, it has a place where you can send me a message. If you could, let me know if you can hear me well and also if you can see me well. So please go ahead. You have to hit enter before to send that, but let me know if you can hear me all right and if you can see me all right. Oh, good. Wonderful. Getting lots of messages. Excellent. All right. I will go ahead and get started. Welcome to Beyond the Weather Brief, quick steps to improving weather certainty. My name is Delia Colvin, and it looks like we've got everybody is hearing and seeing all right. You see where the message board is. If you could send me out, this is the first time you've attended my webinars, yes. If you have attended my webinars before, no if you have not, and then the what your pilot rating is and the city and state that you fly out of. That way I've got a great idea who I'm talking to. Wonderful. All right, we're going to go ahead and get started. And you've got where that red arrow is. So I'm going to go ahead and get started. First off, troubleshooting. If you have any trouble, there is a whole list of troubleshooting steps that you can do. And one of the things that we definitely like about this is that you can go full screen. So you can click on the red arrow and you will get full screen. And here's a whole list of troubleshooting tips. You also have some in your reminders. Easiest thing is to send a message, and Jennifer should be able to respond. Jennifer, say hi to everybody. And you can also send a message to Jennifer in the questions, and she'll be able to help you with whatever whatever you need help with. She's your go-to person for any help. So first off, thank you for joining me. I appreciate your time and your interest in aviation safety. Class audience, it looks like we've got everything from CFIs to ATPs to student pilots and everything in between. So what I'm going to do is I'm going to cover a lot of information. This is a little more advanced class than this is one of our more advanced classes, but what it's going to do is give you an idea of how to actually analyze what you're looking at in the weather. Notes and links. You are going to get the notes and links. The other thing that this does is it actually attaches so you don't have to retype the notes and links, which I'm really excited about. And Wings credits. All you have to do to get Wings credits is be here for most of the webinar and you will automatically get those, as well as feedback. I'm not sure if I think here you automatically get a rating, but if you could shoot us an email and let us know what we can do better, what we did well, we do forward that all on to the FAA, good, bad, and ugly, whatever it is, we just forward it all onto them and let them take a look. And so that they use it to help funding, and I use it to help do anything that I can do. Anything that I can change that's going to make it better for the majority of pilots, I do. I don't tend to narrow my scope to any one area. I tend to broaden it. And so anything that we can do that does that, I try to incorporate. So who am I? I came from Anchorage Center. I started off at Anchorage Center. I was a college student and was a Russian interpreter, so I got to do some cool things at the end of the Cold War. Went into Knoxville Tower and Approach. So I'd worked non-radar, worked some radar, worked some tower, and then went into flight service. I discovered that I was a weather nerd. and spent most of my career in weather, was flight watch trained, and then went to Washington, D.C., where I investigated accidents, incidents, and deviations. That's the main viewpoint that we're going to present from here, is how you can avoid having those accidents. So he got a briefing. It was 8 a.m. Eastern Standard Time for a 10:30 a.m. flight from Alabama, flying back home to Manassas. And he took a look at the weather, says, it doesn't look too bad. And then he departed. Within 30 minutes of his flight, he asked for a deviation to the south, and 30 seconds later, we lost one of our great pilots, Scott Crossfield, who at one time was the most experienced rocket plane pilot in the world. Now, here's the thing. It all comes down to three things. I've investigated a lot of accidents, and probably over 100. And maybe 500. I'm not quite sure how many, but in all of them that I've ever looked at, it has always come down to three things. You always find three factors that if any one of those three factors had not occurred, the accident wouldn't have occurred. So, number one, in weather-related accidents, which is the ones that I mostly looked at, it has to do with evaluating or not evaluating or misevaluating the weather. So I never once saw an accident where we said, boy, that weather came out of nowhere. Ever since we discovered about low-level wind shear, that was one of the big surprises. But since then, I've not seen a single accident. I've not ever investigated one or even read about one where the weather was a big surprise to anybody involved. And for Scott Crossfield, he did get a standard weather briefing that we know of. He got it a little more than 2 hours ahead of time. And what happens is early morning down in that part of the country, you can look fine. But if you have any kind of frontal system that runs through Alabama or Georgia with those mountains there and the warm, moist air off from either the Atlantic or the Gulf, you're going to have monsters, which is what we had. And he wasn't really aware of that. And so 2.5 hours later, it had changed. He did not take a look at the weather. He didn't do an update brief before he departed. Number two factor is that somebody normally sees the situation and does not pass it along to the pilot. Now, in this case, it was ATC. ATC saw that there was a center weather advisory that had been issued for severe embedded thunderstorms. He actually saw the thunderstorms and didn't say anything to Mr. Crossfield. He assumed that he knew about them, and certainly he knew there was something there, and certainly saw that there was some stuff going on there. However, because of that, Scott Crossfield flew right into a cell of extreme precipitation. Now, there is a third factor. We'll get to that later, but there are two growing statistics that are kind of alarming. One of them is that since 2004 to 2014, the number of fatal weather-related crashes during pleasure flights increased 25%. 25%. That is a staggering number. And it was actually, the other numbers kind of dropped down. And so this number was not, well, it's not easy to find. But it is it's extremely concerning. The other is that during that same period, the number of pilots that were self-briefing increased to 93%. Now, what happened is after 2004, when there was privatization, there was a lot of problems with the equipment. It was not a smooth transition, and pilots started going to ForeFlight. They started going to some of these other places to do their pre-flight briefing, and so some of the laws were changed, and they started going with more online services and allowing that. So here's my question for you. We've got a poll. What is the greatest factor inhibiting your ability to make good, safe aviation weather decisions? Now let's just take this little poll here. Oh, there's a couple of cool things that this poll does also. Somebody else asked me why we changed. You'll see. And What is the greatest factor inhibiting your ability to make good, safe aviation weather decisions? This is always fascinating to me, by the way. We have a higher number of, I feel fairly confident. That's not, we have a lot of very humble CFIIs and ATPs, but okay. 32% lack of understanding of the weather, 24% weather product briefing complexity, 25% information overload. So those first three have to do with really understanding what you're getting. 7% taking the time, and 12% I feel fairly confident. I would expect that at least. So here's what we're going to cover today. We're going to talk about the overview and the standard weather brief, what to watch for. I'm going to go through a few more details because it does appear that we have a few more student pilots on this one. What are the weather detection tools and how are they used? And then we're going to evaluate 2 briefings using those tools. Then we'll wrap it all up with the 10 top tips, which is one of the favorite things that I do. And then we'll open it up for Q&A for those interested. So it all comes down to a standard weather brief. And from my point of view, it has, since 2004, it's kind of become a lost art. And I think a lot of pilots aren't really sure what they're looking for. They kind of just jump around and take a look at the weather, whereas there is actually a systematic approach to looking at weather that's a checklist, if you will, of weather items that was established. And it has withstood this test of time, in my opinion. This is 1-800-WeatherBrief.com. This is my favorite site for getting a standard weather brief because it's going to walk you through that, but also it's got some really fantastic features. You can see featured capabilities, and they've got flight plan aids, in-flight electronic PIREP submission. It's got text to activate, text to close VFR flight plans. It's got surveillance, enhanced search and rescue. Next-gen briefings is the main thing that it's got. Next-gen briefings is going to take your briefings from something where, back when I used to brief originally, the big challenge was looking at a ton of material and figuring out what portion of that applies to this route and this pilot during this time. And that's what Next Gen Briefings does, is it eliminates about 40 to 60% of the extra stuff that you have to look at. So really fantastic feature. It is a feature that's only available on 1-800-WeatherBrief.com and on ForeFlight. So both of those have that, and really impressive feature. Now down here it also has how-to videos, and you will notice in the newest update of this, they have FAA just made a decision to take down 644 RCOs, remote communication outlets, for flight service. So when you're flying and you're in the air and you want to pass on a pilot report, if you want to activate your flight plan, whatever you want to do, we have 644 less RCOs, or we are about to. So I would recommend, if that's something that you don't want to see happen, that you get on there and really respond. I think they had 22 pilots respond on this. Anytime I see something like this, I try to make sure that it gets out to the pilots that are on our mailing list. So do respond if this is something you care about. And here's the how-to videos. They keep them very simple, very clean. Now, to get your standard weather briefing, you're going to go to flight planning and briefing. They do have a weather button. That is just something that is going to take you over to the aviationweather.gov page. All right. So why a pre-flight brief? Here's the thing. Number one, pilots are required to become familiar with all available information concerning that flight. The problem is that a lot of times they get overwhelmed with stuff and they think that it has to take a long time. A lot of the pilots that I talk to do. But really, you should be able to do a standard weather brief in about 5 minutes and know exactly what to go to. And I think what we're going to present here is how you can actually really reduce the time that you can do that briefing in about 5 to 10 minutes, where you are coming out of it with some certainty of whether you're going to be addressing. Also, each element of the standard weather brief is designed to provide a varied viewpoint so that the pilot can make a good, safe aviation weather decision. So here's what's in a standard weather brief. And I'm going to bring up my board here so I can draw. Now, the first three items I call part of the overview. The overview is actually a part of the standard weather brief. I like to do it up front. That's how I was taught by the National Weather Service. But I think it really poses a good understanding of what's going on if you know what you're looking at. So I like to look at the satellite. The satellite's going to tell me, is there something that's convective? Is there something convective moving in? Is it stratiform? Is there clouds there? Is there fog forming? Where is it moving to? It's a really great product, and it also tells me sometimes if there's mountain wave, and I can often see if there is turbulence. I can sometimes see it. Then we've got the standard weather brief. Now, in the standard weather brief, you've got all these adverse conditions. Now, here's the one thing that I want to point out. You've got air mats. Air mats are going to be big, broad strokes. They may have them issued when there's a condition existing, or they may not. They have their parameters. They have to at least cover 3,000 square miles and 50% of the area. And they do update them. So if the condition ends, they do tend to cancel them. Sometimes the area is too small, so you don't see it. You have to be able to analyze outside of that, however. And then you've got the SIGMET, convective SIGMET, Weather Watch, Center Weather Advisory, and Urgent Pilot Reports. Those are the rest of the adverse conditions that are non-NOTAMs. TFRs and closed runways are another one. But these, when you see SIGMETs, convective SIGMETs, weather watches, center weather advisories, and urgent pilot reports, what you know is that those conditions are materializing. Now, then we go down to the current conditions. These are all included in most of these are included in the overview. And then we go down to the forecast. Now, in the forecast, the area forecast is supposed to be going away. Most people don't like it because it's kind of broad stroke of what they think is going to be happening with the clouds, and they don't tend to update it. And it's valid for very long times, and it's MSL. And it doesn't tell you if conditions are going to be IFR. You have to kind of figure that out based on what the ground level is under those cloud layers. But it's a really great product, and I'm sorry it's going away. I do understand why. We are going to the graphical forecast, and we'll take a look at that as well. But the point I want to make is that with the area forecast and the winds aloft forecast, these are based on the 00 and 12 Zulu balloon launches. So they tend, and as I said, they tend to not update them. So if you are a long time away from that period, just understand that those forecasts may be wrong. The terminal forecast is the most accurate of the forecast tools, bar none. However, it is a point forecast. We'll talk more about that later. And then we've got NOTAMs. Now, with NOTAMs, one point that I do want to make is that when you're looking at TFRs, we just had a case. As a matter of fact, the pilot was on this call a couple of weeks ago where a pilot looked on ForeFlight, didn't see a TFR, flew right into a presidential. It just wasn't posted for some reason on ForeFlight. I do recommend that you really take a look and see if you've got any TFRs in your adverse conditions on your standard weather brief within 2 hours of your flight time. And if there is anything in that area, I recommend that you get flight following. That's going to keep you out of trouble. Now then, any airport that you are stopping at, any airport you plan to make a fuel stop at, a touch and go, whatever, put it in the alternates as you're checking, because as I said, I investigated accidents and incidents, and a lot of the accidents that we saw were from pilots not checking those airports. So do make sure and enter any airport that you're going to land at into the alternates so that you check what's going on there. Now, these are the weather detection tools. We've got one for IFR conditions, mountain obscuration, mountain wave and mechanical turbulence, icing, and thunderstorms. Now, why do we have different ones for different types of turbulence? Because there's different parameters. And so how these were created is I realized that pilots were going through and looking at the weather, and some of them were shortcutting the weather, like only looking at the METARs and TAFs, because they weren't quite sure what they were looking at with the rest of the tools, and AirMets didn't seem to be terribly reliable. So what I tried to do here is put together kind of my evaluation and the weighted scale of these various tools. Some of them are not even included in a standard weather brief because they're too new to have been included in the requirements. But mountain wave, mechanical turbulence. Now, what is mechanical turbulence for you student pilots, low-time pilots, whatever? Mechanical turbulence is when you have wind blowing over something like buildings or mountains. Usually it's mountains when we're talking about mechanical turbulence for pilots. And it starts eddying. So you think of like a creek where you suddenly have a lot of big boulders, and suddenly the water gets very white and turbulent. That's what happens with the air as well. And so there are very similar parameters when you're looking at mountain wave or mechanical turbulence, for instance, that the winds are at least 20 knots at the peaks of those mountains. And also, if you ever see rotor clouds, that is a sure sign that you've got mountain wave. Doesn't mean that you don't if you don't see it, but if you see it, you got it. So here within the primary products, I have, if you see it, and if you see the condition in any of these, you can just assume that you have it. It doesn't mean you're always going to have it, but you got a very, very good chance of having it. The secondary, I usually look for 2 of those to be forecast. If there's nothing up here, then I'll go to the secondary. And if 2 of these are forecasting it, I assume that we've got it. If one of them is forecasting it, I know we have a chance of having it. So that's how I've kind of put these together. We actually have an app that we're creating that you can use with this. So let's do a flight. First flight is from Binghamton, New York to White Plains, New York at 03 Zulu, and that is 10 p.m. local. You can see the route here now. Here is on this satellite, you can see the Hudson Valley right there. And here are the mountains. Now, these mountains are about 4,200 feet. So immediately you start wondering about mountain obscuration and mechanical turbulence or mountain wave. Those are kind of some of the things that you can look at. And so that's the route that we're looking at. Late at night, we don't often have a lot of pilot reports, but we'll take a look at that. So we have satellite, radar, and surface analysis. Now, what I want you to do is take a look at these, and based on this satellite, now this satellite, right, by the way, is a IR, infrared. That's because it's late at night. We don't have a visible. Visible is the best. It's going to give you more detail. This is measuring temperatures. And so within these temperatures, and actually I'm going to launch another little poll here. And so here, I'm going to let you see what you think is going to happen. You might want to wait till we kind of talk about these before you start voting, but you might be confident. So here is our route right here. And you can see there's the mountains. You can see the Hudson River Valley right there. And these clouds were moving this way. This is our mosaic under the radar. And with the radar, again, here is our route. And you can see there is some precipitation up in the northeastern portion or the northern portion of New York. And then here's the surface analysis. You can see there's a frontal system there. And so we're based on this, I would gather what I think is going to be there, and then we go into the standard weather brief. So right here we have, let's see, 7% of you say none. 79% of you say turbulence, 0% say icing, and 14% say thunderstorms. So let's go through and take a look at what we got. So first off, here is our color enhanced IR and infrared. And again, here is our root right here. And you can see this. Now this is a frontal system. It actually goes up around here. And the reason we know that's a frontal system is because we have the very sharp changes in colors. You can see that right in here, the colors go, and now these are measuring temperatures. So you can see that the temperatures go from orange to very dark blue and white very rapidly. And that is telling you what those colors are. Now you can look on your winds aloft forecast and it'll tell you what that is. So the color enhanced IR I will sometimes use during the day if I don't have a good idea if I'm getting good definition on the visible satellite. But here we know that we certainly have a frontal system there. That is a line of thunderstorms, absolutely. Now behind that line of thunderstorms, we most certainly could have thunderstorms developing. We could have a lot of things. Most often I'm concerned because behind a frontal system, you have a shift of winds. As a matter of fact, sometimes you'll see it in the remarks in a METAR. It'll say FROPA, frontal passage. That means that the winds have shifted, and normally it's about a 180-degree change. And so you'll have to change runways. That's why they post FROPA. And so here, and that frontal system is angled, and so that you could end up with the frontal system actually sitting here over these mountains at 4,200 feet, whereas we saw on the surface analysis it was over here. So there certainly could be some turbulence there. I can still see the valleys there, so I know that pretty much we don't have any clouds that are going to be very significant, but we could have some valley fog. We'll check on that. Now this is a mosaic. How do we know it's a mosaic? Because it's not just showing one condition, one radar site. It's showing a portion of the country or the entire country, or you could use it for the world. And how that is taken is that you have all these radar sites that go around, and they are scheduled to cycle based on what they're seeing. If there's nothing there, they go around in about 5 minutes. That's clear air mode. If there's some clouds there, but they don't look convective, they might take a look in about 7 minutes. If it looks possibly convective, what it's going to do is they're going to circle and do several scans at various angles, looking for the highest level of precipitation in that piece of cloud. It's called, I just went blank on that. I'll think of it in a second. In any case, you've got base reflectivity and starts with a C. I'll have it in a second. And when you see, and by the way, what you want to know is the highest level of precipitation in those clouds. So when you look at your XM radar or data link radar or ADS-BN, it is going to be looking at the highest level of precipitation. But what has to happen is the place that creates the mosaic will go and query the National Weather Service and pull those reports and create that mosaic. And the timestamp on there is once they've created the mosaic. Now that mosaic is larger. It may be leaving off. Some of the reports may not be in. It may not have some of the extreme cells. It may be so condensed that you're not seeing the extreme cells. So just remember that whenever you're looking at your data link radar, that it may not be showing it, and you do need to look at the single site radar to see what it's doing. By the way, we did look at the single site radar and there was nothing there. Now here is our surface analysis, and what we can see here is that these are isobars. They're measuring lines of pressure, and this is moving over our area, but it doesn't look like it's going to be too bad. It doesn't look like it's going to be too bad, although it could bring us some stronger winds. If we're a little stronger up here, I'd be very concerned about what it's going to do down here. Still, winds are certainly a concern. So in our overview, we are looking at possibly turbulence, possibly some mountain wave or mechanical turbulence. Thunderstorms really don't look likely. I didn't see any development of them, although that could happen, but it's late at night and it's getting cooler, so probably not. Icing at summertime. I didn't see any clouds at that altitude, so probably not. And I didn't see much going on in terms of mountain obscuration, although there could be some fog as we go and look at the METARs. There were no adverse conditions forecast for this route. And METARs. Now here is our METARs, and one of the things that I want to talk to you about is that here is the remarks line. Everything after this is remarks, right? So when we've got one that is a little, but everything after the remarks is mostly for the National Weather Service. If you were nervous about understanding at all what goes on with this, the main thing that you want to look at is all going to be up in here. You want to know what the winds are going to be, and if it's late at night and the dew point spreads within 3 degrees, I'm looking to see if the winds are 5 knots or greater. If they're 5 knots or greater, we're probably not going to see some fog. Temperature is going to continue dropping until the hour after the sun rises, and so we always have a chance of fog until that time. But if the winds are 5 knots or greater, then we don't tend to look at this. We're leaving pretty quickly, so I'm not terribly concerned about these winds at 5 knots. Besides that, we'll see once we get there. Once we're airborne, it's mostly clear below 12,000 along the route. Visibility is unrestricted, and as we get to the coast, wind 320 at 11. Look at this temperature dew point. That's not really going to be a factor for us at all. Now, there is an opportunity for you to do clear or plain text with this. And when you go to plain text, I recommend that you actually learn ICAO. It's the language of aviation weather, and it is going to simplify, shorten your briefings very dramatically. Here is what happens when you click on plain text. We've got about 10 to 15 times the data, and there is no way you can look at this and say it's clear below 12,000, visibility is unrestricted. You're going to have to read every single one of these. So do learn how to read ICAO. That's what you're going to see in both the METAR and in the TAF. The area forecast, we have now gone to the graphical forecast. The thing the area forecast did better than almost any of the products that we have, and I'm hoping that that's translated to the graphical forecast for aviation, although I haven't seen that, is I haven't seen evidence of it yet, is that they will forecast thunderstorms, and they do a really great job of it. If it's looking like you got a pretty good chance of having severe thunderstorms, you'll see sometimes just even widely scattered forecast, and usually those will erupt into a lot more. So here is forecasting scattered cirrus. There is no forecast for thunderstorms. I'm pretty pleased about that, so that looks even better. And if the winds were going to be more than 25 knots, I would forecast it. Now, this is the TAF. The TAF is the most accurate of the forecast tools that there are. There's none that competes with it. However, it is a point forecast. It's valid for 5 statute miles around that airport. If that forecaster isn't absolutely confident that that some weather is going to affect that 5 statute miles around that airport, they do not include it in the forecast. They do not include it. So when you're looking at getting your weather before a briefing, you cannot just go through and read the TAFs and say, okay, I'm fine. You have to look at the whole picture. Now here, it's saying that this was issued on the 21st at 23:31 Zulu. It's valid from the 22nd at 00 Zulu to the 22nd at 24 Zulu, also known as the 23rd at 00 Zulu. In other words, it's valid for a 24-hour period. Wind 300 at 5, visibility is unrestricted and clear. That's pretty much what we got. We had wind 280 at 5, visibility is unrestricted and clear. Now, it's not forecasting winds picking up until the morning, so we're in pretty good shape there. White Plains is reporting wind 320 at 11, visibility is unrestricted and clear. That's about what we had. And they're not forecasting gusty winds until the morning. So looking good there. Winds aloft. Now here's where we start looking at this. Now remember that we had a frontal system coming through, and this is forecast for a long time in advance. So here we've got winds. You can see them, and they're not in order, but they are forecasting winds out of the northwest at 25 to 28 knots. That's a heck of a lot of wind. And remember this is forecast MSL. So we are departing from an airport that's at, I think Binghamton's at 1680, I believe. And we're flying, and at 3,000 feet, the winds are supposed to flip around and increase up to about 25 knots. That's a heck of a lot of wind. And you got mountains there that it can eddy around. So you've got a lot of potential problems with that. So if we just looked at the standard weather briefing for you student pilots, you could do this and you're going to be way ahead of just by looking at all those pieces and putting it into a that puzzle. You're going to have a better picture than if you didn't go any further than that. And what you would know is that you had a chance of getting both turbulence and mechanical turbulence, no major changes on what we saw before. So where do we go from here? I mean, we could just say, okay, so it looks like you have a chance. Let's confirm it, or at least strengthen our chances. So here under turbulence, our primary tool is the VAD winds. Now, for those of you that don't know, the VAD stands for velocity, meaning speed, azimuth, meaning direction, display. It is a report. It's actually one of the most up-to-date reports of aviation weather that we get, and it's usable for so many sources. So regardless of where you are and where you fly, I would highly recommend that you add the VAD wind profiles to your standard weather brief. I think it's an incredible tool. Now, if we can confirm it with the VAD winds that we've got something that looks pretty nasty, then we know that we've got it. We didn't see anything in the METARs or the PIREPs that confirmed it, so we're going to look in the VAD winds. Now, we also have a chance of a mountain wave or mechanical turbulence. We're flying through mountains, and so we're also going to look at the VAD winds. We didn't see any rotor clouds, so we're not eliminating mountain wave until we take a look at these. All we're going to say is whether we have mechanical turbulence or mountain wave, or have a chance for it. So here is pilotsandweather.com/Sierra Sierra Romeo, that stands for single site radar.html. This is a site, you should add it to a permanent part of your briefings. I would be checking this like right before you do your flight. I recommend everybody does an update brief before you do your run-up. That's going to give you a lot of information. You can get one sent to you on 1-800-weatherbrief.com. You can actually schedule it, and it'll give you all the graphics, and it will only give you the things that you need that weren't included in your standard weather brief, so you're not looking at everything. Although if you missed that TFR, that presidential TFR in the original briefing, you might want to take another look. So when you go there, it's going to show a single site radar. It's actually my favorite single site radar site. And then as you scroll down, you'll see the VAD winds. Now to select your airport, what you're going to do is you're going to select the radar selection site. It's going to bring up this map, and you're going to choose, hang on a second here, I'm going to go to a lighter color. Now Binghamton actually has a radar site, so we're going to click on that. And here along the left side, this is altitude. Now it's generally going to start the first 1,000 feet above the airport elevation. Binghamton's at 1680, so it's starting at 2,000 feet. Occasionally what you will see is it'll still, let's say that you're at an airport that starts at 4,500 feet, or you're in Colorado or something, and you may see like 1,000, 2,000, 3,000 feet showing ND, like you see up here. It means no data. So first off, this is 2,000 feet. It's going to go all the way up to 50,000 feet. And ND means no data. So sometimes you'll see it down here, and you'll just have to check. When you see a lot of no datas and then you suddenly see significant winds, you might want to check the elevation of that airport. You can just Google it. It's very easy to find out. Now, for those student pilots, by the way, this is the time. And you can see it's updating it every few minutes. And then anything that is green to blue means reliable, which all of these are. Yellow to red means unreliable. So yellow to red would be like bugs or bats or a gust of wind or something that was, and when you see that, then you know that something different happened there. Now these are all, I'm going to scoot down to the next slide here. For those student pilots, winds are named for where they came from, just like people. Like you've got an Irishman, you've got a Californian, northerner, southerner. A northern wind, we call that because it's coming from the north, it's moving to the south, and it carries with it those characteristics. This is a northerly wind, and it is bringing a cold, dry air mass to the area. So it's pointing in the direction. You can almost like add a little arrow there. And these are running about 15 to 20 knots. The long barb is 10, the short one is 5. So what we know is that while the surface winds were 280 at 5, we've got almost a 60-degree change in direction by the time you go from 1,680 feet to 2,000 feet. It's changing 60 degrees and it's increasing 10 to 15 knots. That's pretty significant, especially for you student pilots. Some of you pilots that have been flying for a long time, that might not be something that you're concerned about. Although with those mountains, you might even get some eddies that are a little uncomfortable. So then we go up to 2,000 or 3,000 feet, and we've got 30 knots of wind, and up to 4,000 feet, and we've got actually 40 knots of wind. So we've got some pretty significant winds, and the winds at the peaks of those mountains are going to be out of the north-northwest at about 40 knots. So you bet we're going to have, we have a chance of having some mechanical turbulence. Yeah. I wouldn't say mountain wave here, just because it requires stable and unstable air masses. But here's our final analysis. Severe turbulence and low-level wind shear is likely. And let's go on to the next one. And Ray, I see a great question, by the way. Ray says, how accurate are the cloud tops in the new graphical area forecast? I'm not really pleased with the graphical forecast for aviation and their accuracy. And here's why. The area forecast actually had somebody looking at it. They were feeding it into a model, but they were actually looking at it. So we tended to get pretty darn close. With the graphical forecast for aviation, it will forecast the cloud bases and tops, but it is all based on a model. And you saw with the hurricanes, when we were looking at Irma and what it was going to do, they'd say, well, the European model is saying it's going to do this, the American model is saying this model is saying that, and that's the problem. All these models have different algorithms to determine what's going to happen, and that's what we've got with the graphical forecast for aviation. So you're going to have to see what it's doing and also look at those forecasts. Great question. So here's our next route. We're going Van Nuys to Vacaville at 1815 Zulu. Now, one of the things that I'm always concerned about here is this mountain range right here. These mountains go to about 8,500 feet. The mountain pass is about 4,500 feet, and but at the summit is Gorman, and we have a little area that reports whether it's an AWAS, ASOS, not an airport, called Sandberg. So we'll definitely be looking at that. Part of the problem here is we've got the very cold Pacific and typically the very warm land over Southern California, and so you tend to get a very strong onshore flow, and with these mountains it can create a lot of eddies, a lot of turbulence. Once we get through here, we're at sea level, and there does tend to be a lot of gusting winds through here, but we're landing just north of that. This was a springtime flight, by the way. So here is our satellite, and we're going to launch another poll. Let's see here. And so here you can see this right here that looks like a comma is actually a comma cloud. It's moving on shore. You can actually see that it's already affecting parts of the route. You see some clouds there. Here is the mountain pass that we're going to be flying over, and my concern is the base here. You see some precipitation that is picking up here, And also you see this frontal system. So none of you, I think just a couple of you said none. Most of you are saying turbulence. Now, in California, we don't often have icing. We just don't, and especially not in springtime. The only time that we really see it is if you're going to be flying higher altitude, and if you've got, you certainly can have a lot of weather going on. So here you see that this is convective. That is certainly convective. I see vertical development in there, and contouring, a little bit of contouring. This is kind of an overhead shot, so it's not the best, but you can bet with this frontal system that we've got probably some convective stuff going on. What I do see is up here where we've got Mount Shasta, the white area is much larger than we normally would see, and that indicates to me that there's some convective activity. This would potentially be some thunderstorms right here. However, that's where the mountains are, and that looks more like a dendritic pattern, a tree or branch-like pattern. That is, I believe, snow on the tops of those mountains, although I could be wrong. And then you see here, this right here is the extension of these clouds. Our route is right through here, and so we could very easily end up with some clouds moving into our route. Now, right along here, you see these bands of precipitation. Now, typically, I'm a little hesitant to say this is what we've got, because the problem is with radar is that radar will sometimes, if you've got an inversion, which we wouldn't with the cold front moving in, if you had an inversion, what you could get is it could take that area of precipitation and just move it someplace else. Also, if you have a very dense area of light precipitation, sometimes it can conceal an area of extreme precipitation. But you see the bands, and that kind of went with what we saw on the satellite. So I'm going to have a tendency to believe that this is actually, we're seeing some precipitation. However, in California, because it's so dry, it doesn't often hit the ground. Now you see a lot of this running right along here, but that is because that's where the Sierra is. And so whenever you have the mountains there, you're going to see a little more clouds, a little more precipitation. Or it could just be the radar sites are picking up the peaks of the mountains. I believe it's probably picking up increased cloud levels. So do we have precipitation here? We could. And I see this right down here also. So we're going to look at the single site radars. That's really what's going to tell us what we've got. Now we're landing right here in Vacaville area. I'm sorry, that's a little larger than I meant. But right about here. And so up here you see some light or some moderate precipitation. You see some here also. And that is mostly, I didn't see most of that moving. It mostly looked like it was associated with mountains. So down on this part of the route, the blue means clouds. So I'm not terribly concerned right now about the northern portion of the route. However, we've got a frontal system moving on, so that could change very rapidly. We also have some 2,000 to 3,000 foot mountains that that system has to move over, but it does look like it's moving over it. Now, here is an area. I'm going to change the color of this so you can see it. Here is an area of precipitation, or it's actually clouds, it's blue, and it is actually moving this way. You can see it because as you want to make sure that you animate it. Composite reflectivity was what the word I was looking for before. And you want to make sure that you have it in animation. So here we're looking at, here is the radar site, and you can see that all around here it's got ground clutter. It's actually picking up the ground. It's scanning so low. But this right here has me a little bit concerned because we could end up with some mountain obscuration with that. Or as it's moving over those big mountains, we could easily, we've got the instability there, we've got the lift, and we've got the moisture. We could easily end up with a thunderstorm. And our surface analysis. Now this right here, this is tight enough around here that I would expect turbulence, but you don't know what it's going to do once it moves on shore. Again, our route is from here to here, so it looks like we've got a little while before this is actually going to be moving on and affecting us. However, it could very quickly. This is not a flight. If you were a student pilot or a low-time pilot or somebody that hadn't flown for a while, This is not a flight. This would be my heads up that, nope, I'm not going to make that flight. Because there's too much potential for hazards, very serious hazards. Still, we're going to go through this. We're going to take a look at this. Now, one of the things, see this isobar right here? That tells me that we probably don't have a lot of wind there. So for the southern half of the route, I'm not terribly concerned. However, that could change as we go through this weather briefing. So I'm just going to say that we have a possible for IFR conditions, absolutely, mountain obscuration, all of these adverse conditions are possible with this system moving onshore. Still, icing is not terribly likely. And again, we're doing a VFR flight. So when we pull up, this is what you get on wendytidalweatherbrief.com. A couple of things I want to point out. It's all going to be on this chart right here, this one right here. So, but this is a blow up of it. Now, one thing you want to make sure that you've got this NextGen checked, and make sure that you do not use plain text unless you need to look up something. That's just how that's going to go. Over on the right-hand side, you'll have a little area where you can send yourself an email of this. You can also send yourself a briefing update. And adverse conditions, synopsis, current weather, NOTAMs, forecasts, and NOTAMs. That is your standard weather briefing. That's why I like this. It's one of the few products that really gives this. And also with NextGen, it's going to eliminate a lot of what you're looking at. Now, when you click on adverse conditions, it's going to drop down and give you all the various adverse conditions that you could run into. You'll notice that most of those say 0, right? Air mats is the only one that has a yellow little bulb, but don't go by that. Look for the 0. Now, urgent pilot reports is another thing. Urgent pilot reports only stay in the system for 45 minutes to an hour. So what happens is the center controller will go out and they'll get like 7 to 10 of them, and then they'll just not get them for like 4 to 5 hours because they feel like they've done their job. But the problem is that they drop off in 45 minutes to an hour. So what I would do is if you had a chance of some severe weather, I would look at this because they'll still have it on this chart if they're there, but it will show 0 if it's been more than 45 minutes to an hour. When you click on air mats, you see all of the potential air mats, IFR conditions, mountain obscuration, icing, and turbulence. They've broken them down a little more, and they've got this one for freezing level. That's going to tell you, I prefer to go to that. You know, here's the thing. If you've got precipitation, rain, drizzle, or you're going to be flying in clouds, and you're going to be below the freezing level, then you've got a chance of some icing, especially between 0 and -20. So I usually go right to checking those things. Now it's saying 0 for IFR. That doesn't mean we're ruling it out because we still saw that there was a potential. We are going to take a look at this mountain obscuration one. Now, what you'll notice is that it's only forecasting mountain obscuration on the northern portion of this route. This, by the way, is my favorite map. And you can also animate the precipitation, but it's calling for mountain obscuration in here. Now, we only have hills in this area. So what I would do is I'm not really going to be terribly concerned about that. What that tells me is we've got mountains just to the west that are 2,000 to 3,000 feet, and my guess is we've got ceilings moving in or layers moving in that are going to be covering those mountains, which tells me that we may have cloud layers at 2,000 to 3,000 feet through the Central Valley. But remember, it's close. That is MSL, by the way, when I say layers. If I said ceilings, that would be above ground level. But when I say layers, we're talking of MSL. So the Central Valley is mostly sea level, and so we're mostly talking about the same thing. So it's forecasting icing along the entire route. We're not going to be terribly concerned about that. We're just going to go right over here to our adverse conditions, to our icing chart, freezing level chart. Now this line up here, let me mark it a little differently. Actually, that one's not going to show up very well. This line up here, this jagged one, is telling you that it's 0 degrees Celsius, which is freezing level, at the surface. And then we go to 4,000 feet. It breaks it down in 4,000 foot increments, 4,000, 8,000, 12,000. That's basically what it's running through the U.S. 0 degrees at 4,000 feet. You'll notice that this goes right over where it's saying the surface level is freezing. So you've got multiple freezing levels there, but we're not flying there. We're flying on this portion of the route. Now here you'll see again, they've posted multiple freezing levels at both 7,000 and at the surface. So now you know when you've got multiple freezing levels, you have a lot more chance of running into some icing. And usually it's associated with a warm front that is moving. So sometimes you can run into several problems with that. So if we are staying below, we're going to have to climb up to about 5,000 to get over this mountain pass, but then we can stay pretty low altitude, and I think we'll be fine with that. I'm not going to be concerned about, I've now eliminated icing as a concern for this flight. It's also forecasting turbulence, but I would expect that to be forecast, especially for the northern portion of the route. For the southern portion of the route, that's not a surprise, but we're going to check and see what it's doing. So here we have our METARs. One of the things you can see is that almost all these reports along the route are green, including Sandberg, which is right at the height of this. Now, these METARs are going to be reporting AGL. So when we have this report at 4,200 feet saying VFR conditions, we know that we've got a pretty good shot of making it through there, although we've got changing conditions. So we're not going to count on any of that. Let's go over to the current conditions. Now, the closest reporting point, Van Nuys is not reporting today for some reason. So let's go to the next closest point to the mountains, Whiteman. When we go to Whiteman, Sandberg to Bakersfield, it's an ugly line. Then what we see here is that we've got clear below 12,000, visibility is unrestricted. And really the winds at Sandberg at 4,200 feet are 200 at 10. Now, Sandberg could be kind of protected from where the wind is blowing from, so I'm not going to rule out turbulence, but it's looking awfully good. And remember, that is a point report for right over Sandberg. So there could be clouds moving in from the west, and remember, we saw that frontal system that could be a factor. Now, once we get up into the Central Valley, and also north side of the mountains, clear below 12,000, south side of the mountains, clear below 12,000 or clear. So we're in pretty good shape there. Now, up into the Central Valley, Hanford is almost always 5 in haze. That's just not surprising at all. So I often had student pilots that would need lost aircraft orientations in the Central Valley because they just got lost in the haze of 5 in haze. So if you're not comfortable with 5 in haze, don't fly there. Then we go through we start seeing a ceiling based on that frontal system. It's running, there's an occasional layer, it looks like about 4,200 scattered, then running anywhere from 7,500 to 11,000 broken to overcast, multiple layers above that. Visibility is generally unrestricted, occasionally down to 6 with light rain. So again, if you're not comfortable with that, don't fly in that. And remember, more of that system's moving on shore. However, the surface winds don't look too darn bad. Vacaville is reporting wind calm, visibility 10, ceiling 8,500, temperatures 14, dew point 10. Really not looking too bad right this moment. But again, remember, we got a frontal system coming on shore. Now for this, we still have the area forecast. This right here is for the southern portion of the route. And that is forecasting broken to scattered cirrus. No thunderstorms forecast at all. And no winds over 25 knots, so that's looking pretty good. San Joaquin Valley is forecasting 15,000 broken, tops at 26,000. Now here's the thing, it was actually reporting lower ceilings than that. Or lower ceilings. So, and this is MSL. However, it was lower than 15,000. After 20 Zulu, we're supposed to land at 1930. It's forecasting 8,000 overcast, MSL. So we're actually seeing those clouds. That system is moving on shore faster than they'd forecast in this model. So that gives us a little bit of a heads up. And also they were forecasting light rain after 20 Zulu. Then Sacramento Valley. Now we're landing just on the north side of that line at 1930. Prior to that, they're forecasting 9,000 overcast with light rain. And then after 1930, Zulu, 2,500 overcast, tops at 12,000, scattered light rain showers. Now, if they'd said thunderstorms, I would be very concerned. Light rain showers tells us there's some convective activity, but it doesn't appear to be, they're not expecting it to blow up into thunderstorms. That's a very good indicator right there, by the way. Still, it's going to give us a heads up that there is some convective stuff going on, probably not enough to develop into thunderstorms. And 2,500 overcast, that's MSL. If Vacaville, I think, is about 800 feet, between 400 and 800 feet, somebody could probably tell me for sure. But we're still marginal, and from the Central Valley to Vacaville, I think we're going to be okay. Now, if we wanted to look at the graphical forecast for aviation, we would go to, they have it on here, and that's what they're using right now on 1-800-weatherbrief.com. I don't actually like it. So right here, we've got the tools, and we're going to go to the graphical forecast for aviation. And you're going to click on that, and it's going to bring this up. Now, there's all kinds of different things that you can select. For the you're going to select clouds for the area forecast. But here you could look at the thunderstorms. Now, notice that we had to forecast, I think, for 23 Zulu. We're actually landing way ahead of that time, and it's forecasting a little bit of thunderstorm. There's a forecast right there, so that's close to our route, but I'm not terribly concerned about it because I didn't see anything right now, and as a matter of fact, it's not showing much. Joni says, I'm not a fan of the graphical forecast. Yeah, I'm becoming less excited about it. Now, with the TAFs, one of the things you'll notice is that with the next gen, it's highlighting what your passing time is. And if your passing time has a change within a very short period of time, like here at 24 minutes, it's changing weather. So it's going to let you know that. Great tool. You'll notice that most of these are forecasting VFR conditions all the way up, and the destination does not have a TAF within 5 statute miles. It says nautical miles, it's actually statute miles. National Weather Service and NOAA got into a disagreement with it, and sometimes we see a mix of them now. So there are no TAF stations there, and Vacaville doesn't write one. So what we're going to use is the area forecast that was calling for 2,500 overcast, MSL, subtracting our field elevation from that. However, I would look at what Travis is doing. I would look at what SAC is doing. And what you see here is a ceiling of 5,000 overcast at Sacramento for that time. Travis is right where that wind gusts through, so no surprise that we're seeing very strong winds here. And their visibility 6 with light rain showers, ceilings of 5,000 broken. So that's what they're forecasting at Travis, and about 7 miles away we're going to land on the north side of where those winds gust in. And so we'll probably have that ceiling of 5,000 overcast. But again, remember that system was moving faster than they'd forecast. Winds aloft. Now these winds aloft, what they do is we've got winds at 3,000, winds at 6,000, and they're interpolating them at 4,500 for us. Now if these winds were 180 degrees different, then this interpolation would mean very little. And if they didn't have a report for that airport because it was over 1,500 feet, we're not going to have an interpolation either. So here for the first half of the route, they're forecasting light and variable in the Central Valley and up around Santa Barbara 290 at 10. Northern portion of the route, the winds are going to whip around, they're forecasting, and then they're going to be about 25 knots. That's a big change. So we're really going to take a look at that. So here's our end of briefing analysis. We've got IFR, not likely, mountain obscuration. Now here's my viewpoint on mountain obscuration is that there's a couple of tools that we could look at. As a matter of fact, I think I'll talk about this when we get to after we do our additional tools. Mountain obscuration, turbulence and mountain wave, possible. Icy, not likely, and thunderstorms. So let's go in here and look at thunderstorms. If we were going to look at thunderstorms and you had a convective SIGMET, Center Weather Advisory, Weather Watch, a METAR that was reporting a thunderstorm in the vicinity, radar and satellite on the route that was showing, because you would have to confirm whatever you saw on radar with satellite that there was vertical development, or you confirm that there was vertical development with IR satellite, then I would say you got thunderstorms. We didn't do any of that. We didn't see any of that. However, on the secondary product, it was showing some potential at 2300 on the graphical forecast for aviation. The TAF would be a very good tool. If you saw it forecast in there, we didn't see it forecast in any of the TAFs. So the final tool of the secondaries is the aviation forecast for discussion, or you could look at the MOS bulletins. MOS bulletins are like a TAF, except they're electronic. There's only 666 TAFs across the country. There's over 2,200 MOS bulletins. They are like a TAF, except they're all model-based. They're all just fed into the computer and they spit it out. There's no human intervention on it, but it's updated hourly based on what the ASOS is doing. And so it's a good report, and it's one that I would really use. Now, it's heavily coded. Unless you're looking at the graphical forecast for aviation, you can click on ceilings, and it's going to give you what the ceilings are in those areas in a graphical format, which I think is really nice. That's where that graphical forecast for aviation is going to be really useful for you. Rick says, I find the MOS more accurate than the TAF. Here's kind of my rule of thumb between the MOS and the TAF. If you have a TAF that's 5 hours old and has not been updated because that forecaster didn't notice that there was changes, and the weather has changed, then and you've got a MOS that was recently updated, then the MOS, I would probably look at what the current conditions are doing and look at what the MOS is showing, and I would make a determination from that. If you have one location that has both a MOS and a TAF in there, and the TAF has been recently updated, I would absolutely trust what the TAF says. That's got human intervention, and that's why I like that better. But it just depends on the situation. You've got to make a judgment call on those two things. So let's take a look at the aviation forecast discussion. We're going to go to aviationweather.gov. We're going to go to forecasts. And then the bottom thing here is aviation forecast discussion. Now, why are we going here? Because that forecaster that writes the terminal forecast is going to give us he's going to write out, or she, in plain language, what they think is really going to happen. Now, if you got a lot of weather like we have here, it's going to be longer, but usually it's just like 1 or 2 sentences, and usually it's in plain language. Sometimes they forget that not everybody knows what various terms mean, and you have to look up usually 1 or 2, but it's pretty late. It's a great tool. And if you have any question whether the MOS or the TAF is going to be more accurate, I'd look at this. Now, remember, if this is 5 hours old and the MOS bulletin is showing something very different, it might be that that forecaster didn't see something. So Ray says, where can the MOS tool be found? ForeFlight offers it. It's included with your briefings. Most places, it is so heavily coded. On aviationweather.gov, it is so heavily coded. I go over it in my in book 2 or 3, how to decode it. But oh my God, it's kind of painful, and you've got to figure out where all these. You look at an entire state and it's alphabetical order, and you've got to figure out which ones are along your route, and then you've got to decode it all. So the easiest way is to go to the graphical forecast for aviation, look at ceilings, and that will include some of that forecast. And I believe probably the thunderstorms are also coming off from that tool. But my preferred way of getting that is on ForeFlight. I think they do the best job. So here is our aviation forecast discussion, and you click on the area, and that forecaster writes all the terminal forecasts for a particular area. So he or she is going to tell you what is going on. So here, let's look in the northern portion of the route where we have the most concern, and it says general. It's very long, so I'm going to just tell you which portions are pertinent. General VFR conditions will prevail across the Taft sites today, with periods of light rain developing in the morning and continuing. Now, the rest is all having to do with other stuff. So we've got a pretty darn good report there. And this was not done all that long ago. It's just a couple of hours old, so that's looking pretty good. Although what happens with the frontal system can change pretty dramatically in California, because you don't always see what's coming your way. For the Central Valley, there's a lot of forecasts, but again, we'll just go to what's significant for here. And here it says VFR conditions will prevail throughout much of the Central California interior for the next 24 hours. They're forecasting VFR conditions. And now let's go to Southern California. And this is the one that's high confidence in the 18 Zulu Taft, which was calling for VFR conditions, clear below 12,000, visibility is unrestricted. So we're looking very, very good here. So let's go into the turbulence or mountain wave. Are we going to have an issue? We're going to look at the VAD winds for both of these. We did not see any rotor clouds. So let's go and take a look at that. And what I saw, I'm not going to blow these all up, but basically what I see here is that we had about 5 knots of wind. Now these winds are eddying all over the place. If you can see, these are blowing this way. These are blowing this way. Now, normally, if you saw that, you would be concerned. However, these are 5 knots of wind. We've got a lot of no data in here, meaning nothing detected, really. And so what I would say is that all the way up to about 4,000, 5,000, 6,000 feet, there's 5 knots or less wind. Now, I don't think you're going to run into IFR conditions. If I was briefing a student pilot, I would probably, or a low-time pilot or somebody that sounded nervous, I probably would say VFR flight not recommended. Not because they were going to run into IFR conditions necessarily, but because they could. And you don't want a student pilot or somebody getting nervous, and there's enough weather there that I would just have a tendency to say it because of all the weather. It would be my judgment call that I'm saying that, and but not necessarily because they're going to run into IFR conditions, which is not really the purpose of that, but I still would probably do that. Mountain obscuration, slight possibility, because we still have that bottom of that cold front moving on shore, and it can very rapidly, first off, develop into thunderstorms, and secondly, bring clouds, reduced visibilities, etc. So what I would probably do is depart from Van Nuys, climb up to altitude, take a look, see if I can get through that pass, take a look to the west and see what's going on. And if it looked like I could get through the mountain pass without any clouds, I would just go for it, because right now it looks like it's pretty much clear. If anything happened, I would always have an out. I would go to the east, go to Palmdale, or turn back around, whichever you need to do. And then I would probably, because we don't really know what's going to happen as that cold front moves on shore, I would probably tend to stop at Harris Ranch, have a steak for lunch, take a look at the VAD winds, take a look at the weather, get an update brief, and make a decision from there. That's what I would do. Final analysis. For an experienced pilot, this looks like a safe VFR flight. If you are a student pilot, I wouldn't do it, or somebody that doesn't fly enough to be really confident or competent with this, no way in hell would I recommend this flight. So there you go. The third thing, what are we talking about? The third thing. In the beginning, we said, Scott Crossfield, there are 3 things that I typically find. One is a failure to either correctly analyze weather, or a failure to analyze the weather at all. Number 2 is somebody normally not saying what they knew was going to be a problem. And the third thing that we see pretty consistently, or actually always, is a piece of equipment that is malfunctioning or wasn't used that could have illuminated more data. It's usually a piece of equipment that you wouldn't even be terribly concerned about. But in this case, made the difference. In this case, Scott Crossfield had both a storm scope and XM radar. From my discussions with the NTSB, it doesn't look like either of them were turned on. Both would have showed the center weather advisory. Both would have shown the cells of extreme precipitation. They were fairly stationary, and he would have seen them. Here's the thing, weather-related aviation accidents, you can't control whether somebody tells you about something. You can't always control whether your equipment always works or not. But there is something you can control. You can get a good briefing. You can get a good briefing. And with that, you have very, very significantly reduced your chances of having an aviation accident. Now, understanding weather is vital to your health. I hope you got that from this. Um, it is one of the things, it's one of my passions in life, is making sure that pilots understand that. I've lost family members, I've lost friends, I've investigated a hell of a lot of accidents that I've talked to loved ones after their family members, knowing that their family member had died, and had to talk to them and couldn't tell them, and told them that we were still looking. And it's not a position I ever want to be in, and it's not a position that your family wants to be in either. So make sure that you are taking proper precautions. I started volunteering. This is my 4-minute word from our sponsor. I am the sponsor of these events. We always look, we've been doing these for about 2 years, but I've been volunteering and teaching weather classes since I first started in aviation at Anchorage Center. I was actually used to give tours to the Russian pilots. And have been doing it since. We started doing webinars 2 years ago. I realized if I wanted to do it well, I needed to pay for the software myself, and so I did. And then we had pilots getting bumped off the calls because we had a limit of 100. We typically have well over 100, so I upped it to 500. We've never had a pilot bumped off since then. We started doing it. You started asking for more than once a week. I thought we could bump it back down, but we do 2, sometimes we do 3 classes a week. They're almost always well over 100 pilots. And we just changed webinar hosts because this looks like a much better system. Although this is our first time doing it with you, so I appreciate you we did a little sample class the other day, but I appreciate your notes and everything that you can help us. So when pilots came to me and asked me to put together an aviation course that would be simple to understand, that they could take the information and use it, I listened, and I created a program called the Trio. I believe it's a must for all pilots, because really you're going to be making aviation weather decisions whether you're self-briefing or going through a briefer. It includes 3 on-demand training videos that you can watch time and time again at your own convenience. So we have pilots that often, most of the Trio pilots watch it at least quarterly, and we update it, and you get all the updates. The updates are always included in the Trio. I never charge extra for those, and it qualifies for Masters and Advanced Wings credits. Now, for those of you that participate in the Wings program, and I hope you all do, it's a great program. If you don't want to have a check ride, you have to have those Masters and Advanced Wings credits. And there's very few classes that offer that, the Masters and Advanced Wings credits. So I went down to the FAA and I said, here is our curriculum for our Trio program. Does it qualify for Masters and Advanced Wings credits? And they said, not only does it qualify, each one of the videos qualifies. And I was really excited about that. So not only that, you're going to get Masters and Advanced Wings credits for all of the videos. It's going to give you the vital steps to predicting unforecast severe weather. 3 things you must know when analyzing radar. The 8 pieces of the puzzle that can save your life in specific adverse conditions, and how to recognize and avoid them. I just got a note from a pilot that just finished the Trio today and said, oh man, this was just a great education. I'm starting all over. And I said, don't start over, because we're just doing an update. Wait till we get this update done. The new update should be up in probably, we're going to start releasing that in about 2 weeks. My computer that does the editing crashed on us in the middle of it, and the National Weather Service changed some of the things, so we're just doing some of those. It also is going to include a copy of my book, the book 1 of my 3-book series, The Pre-Flight Brief. This was an Amazon hot new release, continues to be a bestseller, and it's going to be included in this. It's about a 125 to 130 page book. It's got a lot of cheat sheets. We had a student pilot contacted us recently, and he said, oh man, I absolutely learned how to get my briefing from here. And he said, I've taken my book and I've now given it to my CFI so that he can actually use it to teach how to get a briefing, because he said, until I read this, I didn't know. The reason I wrote it is because I was a student pilot that didn't know how to get a briefing. So I was once. And then we've got the weather detection tool chart. Now this is going to become an app, and I'm really excited about this. What it'll do is you'll be able to go through and actually use this as an app to see what you actually have. So this is going to be available to the folks. Now, one other thing that we're going to be including is that each area of the country has its own peculiarities. Certainly, if you're in this area of the country or this area in the country, it's very different from this area of the country. So what we're doing is we've got CFIs that are going to do a briefing on the trio for that area. So if you're flying into that area newly, you'll be able to just listen to that and get an update on all the things that you need to look at and really watch for, besides getting your standard weather briefing. But the peculiarities of that area, there's some very specific things in the southeastern portion of the country and also in California that you really need to know. Those are all over the country. Those just happen to be my areas of expertise. So I'll have a discussion with those, and you'll be able to use those. Also, if for specific flights, you can take a look at things. So we've got, for the next hour, our webinar special. And let's see here. I think we've got it. Here we go. You can just, you might have to scroll down, but you've got it. You've got a link there. We've got the trio, 3 on-demand training videos that you can watch over and over again. We've also got the hazards. It's a bonus video. Now that one is getting recut. We actually recut it about a month ago with the weather detection tools, so that you can go through and take each hazard and say, okay, so for IFR conditions, here's specifically what I look for. Here is the weather detection tools. Here's how it's used. Going into mountain obscuration and how you do that. So you're going to learn with each of those. Then you're going to get a copy of my book, Aviation Weather Made Easy. We're only doing that until we run out of books. We don't have a lot of books left, but that is still staying with the offer. The reason is because we're spending a lot of money to update this, and so we can't always do these things. And weather detection analysis chart, you're going to get that as well. And the first 5 to purchase are going to get a signed copy of the book. We can do that for just a little bit longer. It's a $213 value, and you're going to get it for $129. Again, that price is going up. It's actually higher than that any place else that you go. I do hope to see you on this. I think this is a great program. I'm really proud of it. And the response that I'm getting from the pilots, whether they be student pilots or whether they be CFIs, has been very, very good. And you're going to get, by the way, it's divided into 3 sections. First one, actually 4 sections now. We've got a very beginner section for brand new pilots. Then you go into how to get a briefing and what to do with it. Then we go into the weather, how to analyze the weather, what happens with weather, what creates weather, and how to know and recognize when weather conditions are developing. And then the last part, we walk through a lot of situations so that you will be very good. You'll surprise yourself. You'll get a chance to test your knowledge, and you'll really be surprised how much you know. All right, top 10 tips to a better briefing. Number 1, most important, take the 5 to 10 minutes, sit down, take notes, be attentive. Really be paying attention to what you're doing. If you're going VFR, file a VFR flight plan and activate it. I would recommend you do that on the ground with text to activate and text to close. Do an overview to determine your potential hazards. 4, go through each step of the briefing. 5, make sure you understand the reports and forecasts. If you don't understand something, look it up. Number 6, use 1-800-weatherbrief.com for your standard weather brief. I would actually update that with using the GFA on aviationweather.gov. If you're a student pilot or a low-time pilot, email yourself a copy of the brief. Student pilots, take that briefing to your CFI and really take a look at what that's doing. Have a discussion with it. Let the briefer, if you talk to a briefer, let them know you're a student pilot or a low-time pilot. Number 9, get a standard weather brief within 2 hours of your flight and an update within 30 minutes. And lastly, educate yourself on aviation weather. It is the best investment you can make. Got to get theiritis. About 8 to 10 years ago, let's see, it'll be 9 years this Thanksgiving. I was briefing a pilot. Now, Thanksgiving Day is the busiest briefing day of the year, and there's always a case of got to get theiritis because the turkey is in the oven. And so this pilot had waited probably 45 minutes to an hour. During that time, he'd loaded up his car, driven to the airport, and now I answered, and he put me on mute to load up his plane. As I'm going through the briefing, he was going from Sacramento area through some IFR conditions over a 7,300-foot pass to Reno. I started looking, and it became quite obvious to me that there was a cell developing. Now, how did I know? I looked at the infrared, I looked at the surface analysis, and I could see it on the radar as well. So I said, it looks to me like you got a thunderstorm developing. No response. Sir? Sir? Did you hear that? Yep, got it, thanks. Put me back on mute. Go along a little further. See an urgent pilot report for severe turbulence. Now, this is an indicator of a thunderstorm. What happens is you get the updrafts and the downdrafts that are going right side by side. It can shake you up, and if it's in full development, it can rip the wings off a plane. We actually had a plane that tried to top out a thunderstorm years ago, and he was trying to top it out in Georgia. Not going to happen in springtime. And that cloud, we found parts of his plane in 4 states. So as soon as I saw that, I knew that there was a thunderstorm developing. Tried to get his attention again, just wasn't interested. Got to the end of the briefing. Center weather advisory popped up for severe embedded thunderstorms. Now, remember what I said, when you see a center weather advisory, that tells you you've got the weather. It's happening. It's occurring. And this is a narrow pass, and it's about 2/3 of the way up the mountain. So at this point, I am really trying to get his attention to let him know. I will tell you that I've watched now 4 air traffic videos, radar videos of pilots that flew into storms. Usually what happens is they're a little concerned, trying to get around it, and then the next thing you know, they do something strange. They sound a little disoriented, a little embarrassed. They don't know what's going on, and then the plane drops from view for the videos. So I'm trying to get his attention. Sir, did you hear that center weather advisory? At this point, he's irritated with me. Yeah, I saw it. I said, all right. Well, pilot weather reports are requested. I was about to disconnect. I should have disconnected, but neither one of us did. And then I heard him say, all right, kids, in the plane. And I heard these little kids cheering as they're running to his plane. And I said, whoa, wait, sir? He said, yeah. I said, that your plane? Are those your kids? I said, yeah, they're my kids. I said, do you love them? Because they're probably not going to make it to that turkey dinner. I said, what are you talking about? I said, severe embedded thunderstorms. He said, severe embedded thunderstorms. It was a long pause. Then I heard a door open, heard a door close. And he said, do you think you could start at the top of that briefing? And in about 15 seconds, he decided he was driving. Now, for those of you that don't know, I always tell this story. I wrap it up with this story. And there's a reason for that. You know, a long time ago, I heard about a year ago, we should change out the ending story. And we came up with 5, 6, 7 stories that gave a good lesson, etc. But the fact is, this is the only one I have that has a happy ending. So don't let that be you. All right. I want to thank you all for joining me. I really appreciate your time. We're going to open it up for Q&A in just a moment. CFIs, we occasionally do things that you're able. As a matter of fact, we invited some of the CFIs to help us perfect the presentation moving over. So if you'd like to be involved in that, we're also doing some kind of cool stuff. Send us an email to customerservice@fly-right.com with CFI on the subject line, and we'll add you to that mailing list. Notes and links. We've got the notes and links. They're at this point. Also, you can go and click on the offer, and as you scroll down, you'll see 4 PDFs. Make sure you download them all. Actually, there's 5. There's an old version of the weather detection tools, I believe, on the notes. The newest one is a separate PDF. Wings credits. All you had to do to get Wings credits is be here for most of the webinar, and you will automatically get Wings credits. And if you have any question about it, wait 3 to 5 days, please, and then log on to faasafety.gov. This is a great site. You go in here, you look under advanced credits. If for some reason it's not there, then what you need to do is send us a copy of the reminder that you got. That tells us several things. That tells us the exact webinar that you attended and what your logon email was. So please do that. And then over here in the Wings program, if you're new to it, there's a whole how-to, but they also have a great AMT program. This is a great program that you should be really familiar with it. I'm sure we've got some CFIs that participate in it, but it's a great program. So make sure that you do participate in it. All right, and let's open up for Q&A. Thank you, Clint. Mark says, what's the difference between clear CLR and SKC? So SKC, you generally see where you've got somebody that's actually making the observation. Clear means there is nothing. You go look up and you see blue sky or stars. CLR is usually what you get from an AWOS or ASOS. It only measures up to 12,000. It means clear below 12,000. Clear below 12,000. Rick, thank you so much. And Karen. Hi, Ben. Hi, Sterling. I need to understand satellite IR better. Yeah, satellite IR infrared is really a valuable tool, and you have to know how to read it. And also, it's great for I'll tell you, in the trio, we go into depth on really analyzing satellite and radar, so you get a lot of that. Thanks, Juan. Hi, Dale. Just ordered the trio. Looking forward to it. Oh, awesome. Well, we will make sure that you get a copy of the book. Hi, James. Thank you for the great class. Thank you. Hi, Rick. My first webinar with you, and I have to say it was brilliant. Ah, wonderful. Look forward to seeing you. Hi, Carlos. Thank you. Hi, Joni. Looking forward to the trio. I'm looking forward to it. And I'll tell you what, we're going to do some recordings. And when we do the recordings, you know, it's not always the funnest. It's like being at a live shoot. There's mistakes and there's, you know, edits and stuff. But what I do to make up for that is I spend a little extra time when we do whatever you need to do. If somebody wants to walk through some piece of that, we do that. And we'll make sure you get a signed copy of the book, Joni. Thank you, Steve. Hi, Barry. Thank you. Hi, Will. I will order the trio. I look forward to seeing you, Will. And Tom says, what is a legal briefing? And Tom, that is my favorite question. So what is a legal briefing? If a legal brief is, as I said, the head of the FAA has told me a year ago there is no such thing, that you can do your online briefing, and there's plenty of online briefing tools, and there's no reason for you to not use them. I do still like to use a briefer, And I think if you don't use briefers, they're going to just go away. So you student pilots, low-time pilots, you should groove in getting a briefing and really get proficient with it while we have briefers. Because I don't think we're going to have them for very long, and especially not with the 644 RCOs that are coming down. So remote communications outlets, that's for radio. A legal briefing, as I said, there is no such thing. However, if you go out and you fly and you have an accident, an incident, or a deviation, what flight service is going to do is they're going to do an investigation. They're going to pull where you got your briefing from and check where you got your information. Now, if you did not click that briefing button, enter all your flight information, and click that briefing button, then we don't know what you looked at, and we're going to assume that you didn't look at the right things. That's the assumption. If you talk to a briefer, it's recorded. We know that you got it. There are 5 places where you can get an online quote-unquote legal briefing where it's recorded that I know of. There might be some more by now, but they are 4Flight and 1-800-WeatherBrief.com are my first 2 most recommended. 4Flight, of course, you have to pay for, and it doesn't have the format of the standard weather briefing that I really like. Then after that, but it does some things better, by the way. Then we have, let's see, flightplan.com, Duwatts, I'm not a Duwatts fan, and Garmin Pilot. Those are the ones that I know. There might be some others. Somebody told me aviationweather.com, or .gov, but I am quite sure that is not a legal briefing. That doesn't record it because there's no place to enter in your flight information and click enter. So that's that, Tom. Let's see here. Hi, Alan. Really enjoyed the class. As a student pilot, this was very helpful. Ordered the Trio to keep learning. Oh, great. Well, we're going to, if you say that, then you know I'm going to make sure that regardless of where we're at, you're going to get a signed copy of the book. And Alan, I love seeing student pilots in this. Hi, Barry. Ordered the Trio. Oh, thank you. I'm looking forward to seeing you there, and we are going to make sure. I don't think I've had this many people tell me. That's really cool. And let's see. Oh, so really exciting news. For those of you that follow the flying car, as a matter of fact, there's an interview that we did about 2 years ago. These people flew me up to speak at this event, and I went up there and I did this class. They were inventing a flying car. They'd actually been in business with Steve Fawcett to invent a GA car that could go into space. Steve Fawcett died. They changed it around, decided to make it something very practical like a flying car. It's called the Switchblade, Samson Switchblade, and it is the hottest looking thing. So anyway, check it out. It's really exciting. I am so excited to introduce the inventor and designer of the Switchblade flying sports car, Sam Boesfield of Samson Motors. Hi, Sam.
Hi, Delia. Hey, thanks for having me and for doing such a good job helping people understand and pay attention to weather. Because I fly in the mountains a lot, and the one thing I learned from you is how far I should stay away from those nasty lenticular shaped cloud formations. So you probably saved my bacon more than once.
Thank you. Well, great to hear it. Now, you and your team, you're up in Central Oregon, right?
Yes, we have a R&D hangar at the Prineville Airport. There was a Cessna factory in Bend nearby, Bend, Oregon, which Cessna closed down and took the work to Mexico. So we felt it'd be a good idea to put some of those people back to work making switchblades.
Oh, cool. Now, I've been telling everyone that you are changing history with what you're doing. Tell us about the Switchblade.
Well, the Switchblade is a 2-seat side-by-side vehicle that you can store in your garage, drive to the closest airport, which is usually 15 miles from where most people live in the U.S. You then swing the wings out in less than a minute, do your pre-flight and take off. You fly then to the closest airport to your destination, swing the wings in with the push of a button, and continue driving to where you want to go. So while you're there and driving, the wings are protected inside clamshell doors on the ground, and the tail tucks into the ducted fan in the back there where it's protected by the bumpers. So on the ground, everything's protected.
So we have a little animation here. Let's play this. Well, cool. Now,
Yeah.
what do you have to say to those that are a little skeptical or concerned about the idea of a flying car?
Well, I guess I can list a few reasons. For one, you have the cure for get-there-itis. And by get-there-itis, I mean flying into weather you really shouldn't because you feel you need to get somewhere, like Aunt Matilda's Thanksgiving dinner. You're committed, you want to go, and you get yourself in trouble. So with a switchblade, if you got into weather you shouldn't really be in, you can land, drive under that adverse weather, and take off on the other side of the front once it's safe again to fly. So you're never stopped. So that's one big, big advantage.
That is a huge advantage because I'll tell you, 63% of all weather related fatalities are from pilots flying into weather where they shouldn't be flying. So that is a huge thing. We saw a lot of got to get their itis. So that's awesome. Now, you were telling me about this being one of the safest vehicles ever produced. Tell me about that.
Right. Well, for instance, you don't have to land just at the stall, right as you're about ready to not fly anymore, and perhaps get too far behind the power curve on your approach. With us, you can come in 10 or 15 knots above stall speed, touch down just flat on the runway like you would land an amphib, and then hit the brakes because you've got three automotive disc brakes and tires. You'll be stopped in a heartbeat.
Oh my God, that is so cool. And you were telling me about the parachute. Now tell us about that.
Yeah, you also have the ballistic chute in case you're, say, over the mountains and can't stretch a glide somewhere safe to land. And then on the ground, you've got front and rear crumple zones, side intrusion protection, rollover protection, seat belts, and great visibility.
One of the things you were telling me about, because when you talk about the ballistic parachute, you said that is not for the pilot, right?
Well, most pilots would want to uh, glide to a landing because when you do that, you direct where you're going to land. And so, once you pull a chute, you're at the mercy of the winds and you're going to land wherever. Mostly, and hopefully you'll be safe, and you'll be safer if you try to glide to a landing in the mountains. That's not very safe. But it's mostly for the passenger because if the pilot becomes incapacitated during flight, the passenger who may be not a pilot, may not have a way to get down to the ground safely. So the parachute gives them that capability.
That is so cool. And also I love that the crumple zones. It's like when I start hearing about that, I'm thinking, why aren't all cars made with that? That's
Most cars do. They have crumple zones, but not planes. They're not built that way. And a motorcycle, of course, we're three wheels, class as a motorcycle. So we don't have to have any of that. We just decided to do it because it seemed like that's what should be.
that is just too cool. So, can you tell us about the reservation program?
We do have a way for people to get in a place in line, basically. So the reservation is that there's no money down until after we fly, and even then, I think it's $2,000, mostly refundable deposit. It's refundable for any reason, less $500 for administrative costs until we get into production. At that point, we kind of need to know how many motors and transmissions to build and purchase. So we really have to know that you're in. So we ask you either withdraw the reservation at that point or allow the funds to go hard so we know how much to purchase.
And I think I am way up front on that reservation program. I hope I am. I
Yes.
So, how long have you been working on this project?
Oh, man. Well over 9 years now. It's been a really long pregnancy. Uh, we started out asking the question, what layout should a flying driving vehicle have? Most people ask, how do you make a car fly? And we didn't think that was the right question. So we asked the other. And the answer we came back with was it should have three wheels. That's the lightest stable configuration. You should have the wings and the tail protected on the ground, just for usability, and high performance in both modes. So we knew if we nailed those three key things, we would have a winner.
That is so cool. And you tested the prototype, right? You've done some ground testing, right, on that?
Sure. Once the layout and design goals were established, we built and tested a ground only prototype to prove out the ground portion of the concept prior to getting to the costlier to make composite construction for flight testing. That's really expensive to make mistakes there. So the ground prototype was built to be easily modified. We could perfect our suspension and steering until we achieved our performance goals on the ground, which was nice. We outperformed a Jaguar XK8 in head-to-head acceleration testing. What do we have? The power to weight of a 2017 Corvette. So it's really a blast to drive. It's really fun.
So that's why it is you're calling it a flying sports car because it's got all of this. I can't wait. And you know what? We have a video of the slalom test. Let's show that. Cool.
The GoPro video was of our standard slalom course testing. It shows what it's like to drive it aggressively through turns. And we're very proud that we beat everything in Road and Track's historical database in our wheelbase, the distance between the front and the rear wheels. We have a longer wheelbase than a Porsche or any of the reals, the purpose-built sports cars. But we beat everything in the historical database, and they had 4 wheels and pro drivers, and we had 3 wheels and yours truly.
Wow, that is really exciting. Now, tell us about some of the other engineering and testing, because I've been hearing about it, and it's just like mind-blowing cool what you're doing with this.
Well, it's pretty intense to try and capture everything you need to when you're marrying 2 things together. You have to think in both modes as you do any decision. But, we had full aero engineering done by Dorcorp in Lawrence, Kansas. Then we went into the wind tunnel like Boeing and Cessna because it gets you within 3% of actual. And that allowed us to clear the way so that we can move into carbon fiber composite construction with good certainty of the results. We did a fun little time lapse of getting the wind tunnel model down into the tunnel and set up. And we really hustled, but in fairness, we didn't quite move as fast as shown here. That's my disclaimer.
Let's watch it.
The wind tunnel is really exciting to experience. It's sort of like a miniature mission control for space shuttle launch with monitors and staff hustling around between tests. And we were like a Indianapolis pit crew. They'd have us at the door. They'd have a staff member at the door, and he would make sure the wind was off and it was safe to go in. And as soon as he called go, we were in there, pulling things apart, shifting around, next test. So we accomplished, I think it was over 110 different tests at the Kirsten Wind Tunnel at the University of Washington in Seattle.
That is so cool. How does that compare with commercial aircraft that are, how many do they usually do?
I don't know the total number of tests that they do. I'm sure it's more than they did because they have much more that they're trying to find out at that point. We're more focused on the tail, to be honest with you, in our wind tunnel testing, and that's what we were really focused on. But it was just, I think, the amount of tests per hour of wind tunnel time that was very impressive to the staff there. They had no one in their recollection that ever did anything close to what we did.
Wow. What made you take on this incredible challenge?
Yeah, what was I thinking? Well, artists dream the future, and you can see that in most movies that are of the future. Fifth Element, Star Wars, Star Trek. they all show transportation being in the air. So, you look at that and say, okay, if the future has most of the transportation in the air, and at present we're mostly on the ground, what I felt was needed was that in between step of bringing together the best of both worlds, flying and driving. Doing both well is what I feel will help us be successful.
That is so cool. Now, who are your early adopters for the Switchblade?
Now, the best measure of that is I guess it's 63 people so far who have joined our team through the pre-flight program. Most of these were existing pilots. They were the first to come on board. And of that, we have NASA and Boeing engineers, airline captains, CFIs, and other pilots from a broad spectrum of life. So a lot of those came on early. And although the pre-flights are mostly pilots, there are some who've signed on because they always wanted a flying car. And once they saw the Switchblade, they decided to get their pilot's license. And that's a cool thing for me.
That is really something else. So where are you at in the process of this?
Well, let's see what we have left to finish. We finished the wings and the wing swing, the body forward, the nose, front landing gear, seats, keel up the middle, doors. We're working on windows now. So what's left is to complete the assembly of the tail. All the parts are made. We just have to assemble. Then we have to complete the aft body section where the ducted fan is in the back, mount the engine and transmission prop, and do the interiors and windows. So we have a bit left to go, but we've accomplished a heck of a lot. So that's the big thing, is we're making huge progress. Once we're done with the assembly, then we'll be off to the test flight program and the tweaking that always gets done, because you always have something that comes up in the flight testing. So the wind tunnel gets you within 3%, like I said, but you always have something, control, balance, trim, whatever comes up, we're going to have to handle.
And you actually had this at Oshkosh this year. I can see my flying sports car right there. Okay, so this is really exciting, and I've got my last question for you. I'm gonna put you a bit on the spot here. I've been saying that the Switchblade will be my next car, and Sam, I'm getting about ready for a new one. So, any hint when we might see these on the road and in the sky?
Okay, yeah. Well, let's see. We had really wanted to fly before the end of this year, and that was our goal. We just aren't quite making that target, so it'll be pushed off just a bit. I have to turn my crystal ball in and get a new one, ask Santa for a new one for Christmas or something. It just is not working for me. But with what I see in front of us, I can feel comfortable saying that, okay, you should treat reports on maybe around April 1st of a strange and unusual looking flying vehicle as news and not a hoax.
And that'll be me, hopefully.
You.
All right. And I think we already talked about this. Keep up with the news on Samson's site, on the Switchblade site. And we've got the web address up. And Sam, thank you so much for joining us and sharing your exciting news. I'm so thrilled to watch this.
Yeah, cool, Delia. Thanks.
We'll see you later.
Yeah, you bet.
Bye.
All right, everybody. We're going to close it out. I want to thank you for joining me. I want to thank you for your time and for your interest and for your enthusiasm. Talk to you again soon. We'll see you later. Bye-bye.